3D visualization. In that we will learn the 2D shapes, 3D shapes. Examples of the 3D shapes: mapping of the space around us, the polygon, polyhedron. Examples of the polyhedron, then regular polyhedron versus the irregular polyhedron, concave polyhedron versus the convex polyhedron, and lastly the Euler's formula. So all these particular introductions means the concepts related with everything we will consider in this particular video.
Two-dimensional figures are there, and the next one is the three-dimensional objects are there. Two-dimensional shapes are the square. So this square is a two-dimensional shape. After that, the circle is also the two-dimensional shape, or we can take the triangle. So these are the two-dimensional figures: square, circle, and the triangle, because only the two dimensions are required, and the two dimensions are x and y axis. So it is the x axis and it is the y axis. So it is a plane. Okay, so only one plane is required to draw these particular diagrams. So because of that, these are called as the two-dimensional figures. Now we will consider the three-dimensional shapes. Now in a three-dimensional shape, there are the three dimensions: x, y, and the z axis, like this. So it is the x axis, it is the y axis, it is the z axis, and it is a y axis, and here the object will be placed. Okay, so that is called the three-dimensional figures or the three-dimensional objects. Examples are the sphere, such like it is a ball. Okay, cricket ball, say it is a sphere. Sphere is a three-dimensional object. Then cuboid, for example, cuboid means like this: rectangle box. Sometimes in a gift packaging we will get such type of the box, or the box which is used for packaging the shoes, that is called as a cuboid. This box is called as a cuboid. Okay, so rectangle is there, and such type of the three-dimensional object is there. Next one three-dimensional object is the cube. The cube, that is say it is a Rubik cube which we play, that is the three-dimensional object. It is a cube. So every surface is a square now here in a cube. Next three-dimensional object is a cone, like this, right? So it is a birthday cap, we can say, real-time object. Real object is a birthday cap, or the ice cream cone, that is the three-dimensional figure. So here we learnt related with the two figures. One is the two-dimensional objects, and another one is three-dimensional. Two-dimensional figures are the square, circle, and triangle, and the three-dimensional figures may be the sphere, it may be the cuboid, it may be the cube, or it may be the cone. Okay, now we will discuss some of the examples of the three-dimensional objects which are real life. Take the example of the pencil. So the pencil consists of like this. So if I draw the diagram of the pencil, it will be looks like this. So upper portion, this portion is a cone, and the lower portion is the cylinder, right? So pencil is a combination of the cone and the cylinder, these 3D objects. Next one is the ice cream. So ice cream will looks like this. So one cone is there, and on above this particular cone there is ice cream, like this, right? So this is not the complete sphere, so it is a hemisphere, and the below portion is the cone. So cone plus hemisphere, it will make our ice cream. Okay. The next one is a circus tent. Circus tent. Okay. So if you look at the circus tent house, it will looks like this. So such type of the, on a bottom there will be, and on a top there will be one prism. So such type of the tent will be there, circus tent. Now it consists of the top portion here, this top portion is consisting of the what? It consists of the pyramid. This is called as a pyramid, right? And the bottom is, as usual, it is a cuboid. So pyramid plus cuboid, it will constitute the circus tent. Okay. The next concept is mapping of the objects around us. So now it is very easy concept. So if you make the top view of our living room or the study room, it will looks like this. Okay. So somewhere from here we will have the entry. Say it is a entry. Once it is entry, there will be some TV. Say the television is there, TV set is here. Okay. Then after that, maybe here we have the bed, right? Here the study table will be there, study table, chairs will be there, 2 chairs will be there, right? So such type of the layout of our room will be there. So this is called the mapping of the objects around us. So we can represent the objects which are around us by using such type of the mapping. Next one is a polygon and the polyhedron. Polygon, as we know, it is a two-dimensional shape. It is a two-dimensional shape, or it is a two-dimensional figure. It should be the closed figure, and it should be drawn using the only the straight lines only. Straight lines. So these two are the very important. It should be the closed figure, as well as it should be drawn using only the straight lines. For example, this is a polygon, and it is not a polygon, it is a polygon, like this. So polygon is a closed figure, it is drawn using the straight lines, and it is a two-dimensional shape. So depending upon how many sides are there, how many sides are there, we have the different types of the polygon. If the polygon has the 3 sides, it is called the triangle. If the polygon has the 4 sides, it is called the quadrilateral. If the polygon has the 5 sides, it is called the pentagon. Then if the polygon has 6 faces like this, it is called as a hexagon. If 7 sides are there, then heptagon. If the 8 sides are there, then it is an octagon, right? Like this. So we have the different special meanings for the every type of the polygon, depending upon how many sides are there in that polygon. Now what is polyhedron? So polyhedron means, take the example of the cube or the cuboid. Like this, in which all the faces, this is the one face, this is the second face, third face, and it is the fourth face, fifth and the sixth faces. So cuboid has a 6 faces. All the faces are the polygon, means they are the rectangle, means it is a polygon. If all the faces are the polygon, if all the faces are polygon, and every vertices touches equal number of the faces, every vertex touches equal faces at that particular time, we can say that it is a polyhedron. Okay, consider this particular vertex, it is touching this particular face, this face as well as this face, means it is touching with the three faces. Take the example of this particular vertex, it is touching with this face and the topmost face, like this. So every face should be the polygon and every vertex should touch the equal number of the faces, then it is called as a polyhedron. An example of the polyhedron is a cuboid. Okay, now the regular polyhedron. So regular polyhedron will have the all the faces will have the regular polygon. Take the example of this particular, this face has a regular polygon, that is a triangle. This face has a regular polygon and the face which is beyond that, that is also having the triangle, and below one, that is also having the regular polygon, that is a triangle. Now take the example of this particular cuboid. This is a regular polygon, regular polygon, regular polygon, regular polygon, polygon, like this. So every face will have the regular polygon. So this is called as a regular polyhedron. And one more feature related with this regular polyhedron is that there all the vertices touches the equal number of the faces. This will touch the three faces like this. It will touch the 1, 2, 3, 4 faces. It will touch 1, 2, 3, 4 faces. It will touch 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5 spaces. Again for every vertex, this vertex is touching 1, 2, 3 faces. Take the example of this vertex, it is touching 1, 2, 3 faces like this. If the polyhedron will have the regular, every faces will be the regular polygon. If in a polyhedron every face is a regular polygon and every vertex is touching the equal number of the faces, then it is called as a regular polyhedron. Reverse to this is a irregular polygon. Now take the example of this particular prism. Here it is a rectangle like this. This face is a rectangle. Face which is beyond this is also rectangle and the bottom face is also the rectangle. Whereas the two faces are the triangles. These two faces side. Okay, means faces will have the different polygons. One thing. Second thing is that every face will touch. It is not compulsory that it is touching the equal number of the faces. For example, this is touching 1, 2, 3. This is also touching the 1, 2, 3. This is also. Every vertex is touching the three faces, but the difference is that every face is not the regular polygon. Here in this particular case, this vertex is touching 1, 2, 3 faces. So every vertex is touching the three faces, but this is what 1, 2, 3, 4, 5, 6, 7, 8 is the octagon. The topmost face is the octagon. Bottom one is also the octagon, whereas this side is a rectangle. Okay. Now vertex is touching the three faces, no doubt, but it is a octagon, it is a rectangle, it is a rectangle, it is a triangle. So if there is some mismatch in between, the face should have the regular polygon and every vertex will touch the equal number of the faces. At that time only it is a regular polyhedron, otherwise it is a irregular polyhedron. Now these two examples are of the irregular polygon. This is the Euler's formula. In a Euler's formula, it will states that the number of the faces means f value. Okay. Here in this particular figure, the number of the faces plus the number of the vertices minus number of the edges this particular is equal to the 2. So this equation is nothing but the Euler's formula. Take the example of the cuboid. In a cuboid, the number of the vertices are the 8. How? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Number of the faces: first, second, third, fourth, fifth, sixth. 6 faces. Number of the edges: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So keep it in a Euler's formula. Number of vertices are the 8 plus number of the faces, number of the edges, that is the 12. Okay. So what comes is a 14 minus 12 is equal to 2, like this. How many edges does the pentagon prism have if it has a 7 faces? How? 1, 2, 3, 4, 5, 6, 7. 7 faces. Faces are the 7. How many vertices are there? 10. How? 1, 2, 3, 4, 5 and 5, 10. So 10 plus number of the faces minus number of the edges, we have to calculate. Minus 2 equal to 2. So the 10 plus 7 is 17 minus 2 equal to edges. So edges will be equal to the 15, like this. So by using the Euler's formula, we can find out this particular absent value, that is the edges.